This conference will now be recorded.
Yes, sir. So today here we are for display design demo. Today we are seeing the PD demo, right? So in this PD demo, so what we are going to discuss? First, I will mention that. See, first we will discuss about courses in VLSI Guru, right? What are courses offered, right? Next, I will discuss is course plan, the closes, how the course is planned, right? Next, I will discuss about what is physical design. Next, why physical design? Topics covered in physical design. So what topic we cover in the physical design? What that means? Again, can tell about means the meaning is what is the course content. And finally, if you have any doubts, right? Doubts is addressed. This is what the topic what I'm going to cover today. Right. So what courses we cover in VLSI Guru? So the course we cover in VLSI Guru is so content RTL design, design verification. These are the big courses. I mean, it is for like 5 to 6 months. All these courses are right. RTL design, design verification, DFT, design for testability, physical design, and we also cover layout. Layout. These are so even FPGA design. These are the courses for 5 to 6 months. Even we have very short-term courses for like only scripting, TCL, Python, and some protocols for design verification. Like if you have any protocol, Ethernet protocol, DDR protocol, or some other protocols. So small courses for 5,000, 10,000. You have even courses for that. So even we have course for synthesis and STA. Even this is also big course, but this course is not available. Like it is only available online. It's not available offline. Means live training is not available for synthesis and STA. All other courses live training is available. Synthesis and STA is e-learning course. And even you have courses like Innovus Flow. Since if anyone is knowing synopsis flow, if they want to know cadence flow, so then we have Innovus Flow, and even we have IC2 flow. So we have TCLC. All these are not live training, it is e-learning. But all other things, all whatever I mentioned here, all these are live training, right? So e-learning courses are synthesis and STA, means the recorded videos will be given for you for this courses. So you have Innovus Flow, you have IC2 Flow, you have TCL scripting, Python, like this. So all these are small things, and even protocols. Front end, right? Whatever front end you have, in that you have also called as what? Protocols. What the protocols? If you want to learn DDR protocol, so all this information is present in e-learning courses, right? But all above courses are live sessions. So now you people are interested only in what? See, physical design. Now you are interested in physical design. All other type of courses that the demo is already done. So now we are interested in physical design. I'll tell only about physical design plan. How the plan is going to work for physical design. For physical design, we need a basics. To do physical design main course, right? We need a basics. So basics is digital. You want Unix. Unix is nothing but it is you have a operating system called as Linux operating system or Mac operating system or Ubuntu operating system. So all this operating system, you can easily access this operating system or you can easily interact with operating system by using this Unix commands. See, if I want to create 10 folders in this Windows, how do I create? Right click, new folder. So one is P1. Next again, right click, folder. So 10 folder 10 times I have to do. But in case of Unix, right, directly use only one command like this. mkdir P1, P2, P3, P4, P5, P6, P7, P8, P9, P10 means create this 10 folders with name what? One folder with name P1, another folder with name P2, another folder with name P3 like this. This is a mkdir is a Unix command. So like this, right? How to use the Unix command, how to interact with operating systems by using Unix command, right? That you are going to learn all the Unix commands. So next is you need PCL or GVM basics. The GVM is a text editor. Whatever I'm using is now what type of editor? It is a text editor. So GVM is also one kind of editor. So if we use that GVM editor, it is very much helpful for it is very much helpful to do file operations. If I want to search anything here, how to search it? For example, I want to search a physical design keyword. I use how do we search? Press Control F, type what? Physical. So my tool is nothing but physical design. Similarly, how to search by using GVM tools. How to search by using GVM editor. If I want to get line numbers here, how to do it? No, no option to get line numbers, right? But in GVM, you can get the line numbers, even line numbers you can get. So what are the commands? How to use GVM is nothing but an editor. This one of the text editor, GVM is also one of the editor. So how to use the GVM commands to use to access this editor? Industry uses only this GVM editor. They never use text editor. Right? You should learn this. Then you need CMOS basics. You already learned CMOS basics, but still we'll cover CMOS basics. Like what do you mean by semiconductor? What is P-type diode? What is N-type diode? What do you mean by FET, field effect transistor? What is NMOS? What is PMOS? What is CMOS? What do you mean by layout? How to draw different CMOS circuits? So all those concepts is covered in CMOS basics. Then after CMOS basics, a small PD basics. It's only for 2 days. We'll do PD basics small. Like some terms in PD, like what do you mean by cell delay? What do you mean by transition time? What do you mean by power? Power in CMOS. So to cover that, we do PD basics. So all these things will come under the category of what? Basics. So this will go for 2 months. If you opt for basics, see, opting for basics is optional. You need not to go for basics. If you want basics, you can opt for basics. So next we have advanced part, advanced physical design. So what topic is covered in physical design, I'm going to cover later. During the flow, I'll cover. Right? I cannot cover now. But still, I can tell you what we do in advanced physical design. See, in advanced physical design, we discuss all the concepts of physical design, theory, and lab. In lab, we do 2 projects. Industry level projects we do. Right? So theory is done on weekends, Saturday and Sunday. It's for 3 hours. Saturday 3 hours, Sunday 3 hours. So theory is done. So lab. So lab again we have two parts. One is weekdays lab. This is from Monday to Thursday. Next we have weekend lab. It's only on Saturday and Sunday. Friday is a holiday, right? So now what is this weekdays lab? See, weekdays lab is only for the students who can attend on weekdays. And weekend lab is only for the students who can attend only on weekends. If some of the students cannot attend, or some of the attendees who cannot attend on weekdays, they can attend only on what? Weekend. But the students should not attend both the labs. Either you can attend on weekdays or you can attend on what? Weekend. Same syllabus is covered. This we have planned a weekend lab because only for the students who cannot attend on weekdays. Some will be working professionals will be there. Right? For them, we are planned only for weekend. So weekend is lab is only for weekend students. Weekdays lab is only for weekday students who opt. You can opt whatever you want. Fees is same for both. But theory is on weekends for everyone. For weekday students and weekend students, both the theory is on weekends. Right now, so you attend theory on Saturday and Sunday morning, and weekday students are free. Saturday and Sunday after the theory classes, they can go to home, and weekend students they will be having lab after the theory classes. So Monday to Thursday, lab will be done for weekday students. So we are going to do 2 projects with 14 nanometer technology. Right. So this is a plan for course. So basics course will be there and advanced course will be there. So advanced course may take for 3 months. 3 months is a time for advance. So it will complete in 3 months. Max to max due to some reasons. All right. It may get extended 15 days extra. Like it can be for 3.3 months to 3.5 months. It depends upon the holidays in between, right? If you opt during this October time, there are plenty of holidays. October time, you have Dasara, you have Deepavali, right? Plenty of holidays. So if that is the case, it may extend till 3.5 months. If holidays is very less, it will close within 3 months. So total time for this PD courses 5 months. It may extend till 3.5 months. And basics happens from Monday to Saturday. There is no weekend like this, right? Monday to Saturday. Happens. Any classes for some reasons. Right? What is the optional you have here? Some reasons if you cannot attend some classes. For example, you are absent for one class. Then how do you cover this? See, for this reason, right, what VLSI Guru has done is he will give the live recorded videos. See, there are two videos. One is pre-recorded videos. Even this videos is given to the students. Pre-recorded videos. This video is available till course end. Course end. These videos are available. It's pre-recorded. Means this recorded recording has done some other time before 1 year or 6 months before they have done the recording. But even we will give live recorded videos. For example, if you miss the class today, we will give the live recorded video for you for today's class, right? But it will be uploaded 4 hours. Today the class happens between 9 to 12 minutes. The video will be uploaded in the 5 o'clock evening. They will give the video at 5 o'clock evening. Alright, every class they will give the video. And this video will be available for next 15 days. You can see the video within what next 15 days. For example, if you are absent today, for some reasons, morning you are not able to attend, night you can see the videos, or you can see the video in next 15 days. This is not the pre-recorded video, this is a live recorded video. Means the classes which is currently going on. Unfortunately, you are not able to attend the class. Then you will get what? Live recorded videos for next 15 days. So thereby you can make up the classes. So apart from that, you will be having regular test and mock interviews to make you ready for interview. This is the course plan what you have. Right. So what is covered in course? Advanced physical design course I will do later now. What is physical design? What we do in that. But now any doubts in course plan you can discuss. Now you can ask me the questions. If you have any doubts in course plan.
Good morning, sir.
Yes, good morning. Please tell me.
Hello. Sir, you will teach us Verilog also in this course?
No, this is not cover very long.
Uh, okay, sir.
See, because for physical design, much knowledge of Verilog is not required. See, you want Verilog of only what do you mean? What do you how to write the small module? I think it is covered in UG classes. So too much knowledge of Verilog is not required for physical design. It is required for synthesis and STA. But for physical design, too much knowledge of Verilog means RTL knowledge is not required. See, we teach Verilog. I'll tell you what we teach, right? See, we teach what is netlist. See, we work on synthesize netlist. So we teach what is how the synthesis netlist will be. The input files we'll discuss, but will not teach the Verilog. RTL will not teach.
Okay, sir. Got it, sir.
We'll teach what is synthesize netlist is. That will be.
So the weekdays actually, what's the duration?
3 hours.
So who will teach for it? Same, same faculty.
See, weekdays some person will teach. I am not sure who is going to teach. Some of the persons from institute will teach them.
Only for the theory classes, excursion.
See, I'll confirm about this. Yes, 1 second. Please, 1 second. One student in offline class is asking doubt. 1 second, wait. So, see, this theory classes is done on weekends with only intention that the industrial expert is going to teach. Industry expert who is already working in industry, those who are going to teach. So, lab is also done by some of our experts. It's not that he's a fresher, he's already expert, he has done many labs. It will be guided from this industrial experts only. They will only guide the thing, but they cannot do on weekdays because they are industrial experts. They are working in some other company. We cannot ask them to teach them. So lab is done by the experts only, but it is guided from the industrial experts itself. They will guide how to do the lab. Right? It is not like there is no monitoring. So the person who is doing the theory will monitor what is going on lab, but they cannot teach the lab because they are already working in industry. They have the work pressure to handle. Even on weekends also, right? Weekend lab also done by the expert from the institute. See, duration for lab is 3 hours. The duration it will be on in the morning generally. In the morning generally it will be from 9:30 to 12:30 for weekdays. Sometimes it may be at 2 to 5 afternoon. It depends upon, see, 2 to 5 is very less chances, but generally it will be from morning 9:30 to 12:30. When we come to weekend lab, so weekend lab will be present after the what? After the weekend theory. So weekend theory will be in the morning from 9:30 to 12:30. After that, you will be having lunch break till 1:30. Again, you will be having lab from 1:30 to 4:30. Right, like that. It is like that. After theory sessions, you will be having lab for weekend students. For weekday students, there is no lab after theory classes.
Hello, sir. Sir, I have one more doubt. Like all the things related to the tools, you will teach us in just PowerPoint or like in tools, sir.
Yes, yes, see, that I forgot to mention. Thanks for remembering. See, students will be given ICC 2 Campus and BC compiler tool as VPN access. You are going to access the tool. So you are given VPN access. VPN means virtual private network. From your laptop, you are going to access our server. Our team will help you how to access that. But you should be having internet. Or you can come and access through the institute itself. You can come to institute when lab is happening, right? So you from your laptop you will be accessing our server. From our server you are going to open the tool. You are going to do real hands-on. So lab is real hands-on experience. It's not done through PPTs or some other things. It's real hands-on. Real hands-on means you are going to work on the tool. Even the mentor or trainer is going to work on the tool. So he will do it. The steps you are going to follow it, and he will give the assignments. You should do that. So this, what I mentioned, right? Tools. This is given to all the students who are going to register for the course. It is 24/7. You can use the tool. No, no. If you opt for
Okay,
basics,
sir.
when your advanced course started, then only this tool starts. In
Or
advance
sir,
starts.
you will
Please
give
continue.
tool access just for the 6 month or till get placed, sir.
See, this course starts. We are not going to give the tool when their basics is happening. For basics, tool is not required. And with the tool, you are not going to do anything when the basics is running. Right? For basics, you want some other tools like how to do TCL. But these tools are very costly. These tools are given when the advanced course starts. So advanced course is for how many months? 3 to
Just for 3 months,
3.5
sir.
months. The tool is
Yep.
given till the course ends. So even after course is ending, the tool will be extended for next 15 days. If, for example, if our course is going to end today, so we are not going to cut the tool for today. The tool access will continue for next 15 days through VPN. VPN means you can access from your home itself, right?
Yes, sir.
So
Got it, sir.
VPN, through VPN, I have not yet completed. Through VPN, you can access the tool for next 15 days after course completion. So course is completing today, then next 15 days you can use the tool. You can practice the tool. But if you are
Okay.
coming to VLSI Guru and if you are accessing the tool, you can access till you get the job.
Okay, sir. So
From
it
home you
means
cannot
if
able
I
to.
come
See,
to
if we
Bangalore
give
and join
home
the
login
VLSI
to you,
Guru,
right, it is not sure that you are using it. Some other person also can use it from your laptop. You can sell the tool.
yes, sir. Yes.
All this are happened internally for us. You can sell the tool to some other person. Industrial process tool is very costly. EDA tools are very costly. See, we have to pay in lakhs to get these licenses. Right?
Okay, sir. Okay. Okay. Sir, VLSI
So
Guru
we
also
will,
providing the
yes, continue.
sir, sir, VLSI Guru also providing the placement assistance.
Yes, sir. See, VLSI Guru is tied up with many companies. So whenever any companies have a requirement, they immediately contact to our team, placement team. So our VLSI Guru is going to take your resumes and they will forward to the companies. All right.
Okay,
So
sir.
they will
So
give the
we,
placement
so
assistance till you get the placement. But
okay, sir.
what VLSI Guru does is for forwarding the placement, say they will do the mock interview before sending your profile to the companies. Mock interview
Yes,
they
sir.
will do internally, right? If you are clearing this mock interview, then only they'll send your profile to the companies. Why I'll tell you why this process happened. For example, the student who was not at all prepared, who is not at all serious about his career, if we forward his profile to the company, company will feel bad for VLSI Guru. They are sending us some dummy profiles. The student is not at all capable of even talking in English. Then what happens? It is going to affect the placements of even other students. They may not come to us again if we send some candidates who are not efficient. For that reason, what we do is first
Okay,
we
sir.
do mock interview, then we will send the profiles to the companies if the mock interview is good. First thing, if your communication is not good, even we have communication classes also. This is done free of cost, I think. So there is no additional
Okay, sir.
charges taken on this. So communication classes happens if your communication is very weak. English is weak.
Okay,
Means
sir.
they will do
So
communication
so
classes.
VLS. Okay, sir. So VLSI Guru provide placement assistance for MNC company, or you will just try to place us only in service company, sir, which you prefer most, sir.
See, I will tell you only one thing. Product based companies. See, I will tell you about this placement very clearly. Everyone listen it most carefully. See, product based companies are the companies who are going to fabricate their ICs. So, what are the examples for that? Intel, Qualcomm, AMD, Nvidia. See, generally these companies will hire only 3+ years candidates. I am working in
Okay,
VLSI
sir.
domain only. They hire only 3+ years candidates. They will never look for the candidate which is below 3+ years experience. Means because these companies will not invest many things in training. So they hire only 3+ years candidates, these product based companies. Now, I am not telling that they are not going to hire any freshers. They will hire freshers in two cases. One is they will hire from top colleges like NIT, IITs. They will hire from that. Second thing is these companies will give some internships to some candidates on some priority basis or some reference basis. If they are good in internship, they may hire. So apart from these two conditions, probably they will not hire any freshers. Right. So now the gate for getting into product-based companies directly is closed. When you go to from any institute, see institute will claim that I will send you to product-based companies. That happens only if your profile is very good. Means if your profile tells that you are from some top institute, you are having 90+% of marks. So then you are very good. Even there is a chance that you can get into the product-based companies. So product-based companies hiring freshers, right? They will look into your profile, not on what knowledge you have. Well, see, they will select the resume, all right? So they will select
Yes,
when
sir.
only when you are from that good institute, like that. So second thing,
Okay.
you have service-based companies. Service-based companies will work for the projects of product-based companies. Product-based companies, they themselves will not do any projects. They will outsource all the projects to service-based companies. See, there are many service-based companies like Silica, Smart SOC, even Samsung is service-based company to Qualcomm, Sientra, correct? And even there are secondary service-based companies. Service-based companies below Capgemini is also one of the service-based companies. These service-based companies is going to work for the projects of product-based companies. Right? For example, the engineer from Capgemini will be working on the projects of Intel, right?
Yes, sir.
So I'm telling in VLSI domain. So this is called a service-based companies. So service-based companies, they will hire freshers. They will train to that level of expertise, like 3 years experience expertise, and they will post you as a 3 years experience guy. That they will do it. So getting into service-based companies is most probability is more going to service-based companies because they even hire freshers. They will train them. Training means they will not train you how we train in VLSI group. They will train you what projects you should tell when the client is asking you what projects you have done. There are some industry standards project, right, which is very confidential. They may not tell outside, but they may tell to their
Yes, sir.
employees. They will tell all these things. So they'll tell this for 1 week or 2 weeks, then they will see, this is unofficial, but still I'm telling you. Then they will project you as 3 years experience, even though you're not 3 years experience, but they will project you as what 3 years experience, and they will send you to the product-based companies project to work.
Yes, sir. Got it,
This is
sir.
how it's going to be. Product-based
Sir,
companies
I
will
have
never
one
hire
more.
the candidates freshers. They will hire only three
Yes,
plus
sir.
years experience. Even though if you are
Okay, sir.
going for service-based companies, you cannot go to product-based companies if you are a fresher. Your service-based company tell that you are a fresher, your product-based company will never hire you. So what the service-based companies will do is they will train you on some aspects. They will project you as 3 plus years experience or 2 plus years experience, and they'll send to the product-based companies project. One thing. Second thing, there is a project called as ODC project. Means product-based companies will sell entire project to the service-based companies to do. So, for example, Qualcomm is asking the Sientra or Silica or Capgemini to do the entire project. So, all the employees of Capgemini will work for this ODC project. In this project, even freshers can be used. So, in this aspect, only
Okay,
the
sir.
freshers will come into picture. So, directly going into
Understood, sir.
product-based. Now, how to go into product-based companies? So, you are working for the projects of product-based companies. If your performance is very good, if you have learned, if you have enough knowledge, if you are impressing your product-based company manager, they may hire you. So many of them have went in that way, that basis only. They will work initially in the service-based companies. After 3 years, they will jump to what? Product-based companies with good knowledge. This is how it's going to happen.
Okay, sir. Sir, I have one more doubt regarding the TCL, sir. So, when I was looking the TCL course in PD and the TCL course separately, which is mentioned on your website, sir, the course content in both are totally different, sir. Like in particular TCL course, there mentions file handling commands and so many lab sessions. But in PD course TCL, these things are not mentioned there. Why is it so, sir?
See, there is two types of TCL. One is basic TCL. So here I have not mentioned TCL, right? Sorry, I forgot to mention TCL here. I'm very sorry. Even TCL is covered in basics. They're going to cover. So here it is basic TCL. Basic TCL is nothing but TCL. We are going to learn what is a syntax of TCL, how to use TCL, right? So one is called as advanced TCL. How to use a TCL for the physical design. How to use a TCL for the front end design. How to use TCL for synthesis design. Now this application oriented TCL means whatever TCL you learned here basics, right? how to use for physical design.
Yes, sir.
So if you take TCL course, both is going to cover, right? You have basic TCL and you have advanced TCL. So you can take both basic TCL and see, I'm talking about TCL course. I'm not talking about physical design course right now, right? You
Okay.
can
Okay,
take
sir.
both the basic TCL and also advanced TCL. But some students will be knowing basic TCL. They are already knowing because you can learn even in YouTube also. This see whatever you learn in YouTube is not going to cover what we teach here for sure. But still, some students tell that okay, I know TCL. Then this TCL is not required. Then you can only opt for what? Advanced TCL means how to use TCL in physical design, how to do automation. So thereby the topics differ. So advanced TCL
Okay,
tells
sir.
that in physical design, the TCL tells that how to use this basic TCL in this advanced PD concept. So if you opt for TCL, if you are opting for TCL, for example, right, you tell that okay, I'm opting for TCL. Then you can opt even basic TCL plus advanced TCL.
Sir, is this
Now
the
I
other than the physical design, sir? Like on the same price, sir? Advanced TCLs and the PD course, all kind of things.
see TCL is used for automation purpose, right? How to do flow
Yes,
automation,
sir.
how to fix some issues. So some concept is discussed here. See, even so, I'll please give me 2 minutes. I'll complete this first. Even in our course
Oh,
plan, basic TCL is done. If you in the physical design course, even basic TCL is done. This is done for 10 days. Even we cover advanced TCL in the advanced physical design itself. But what is this entire course is? It's almost around 50,000. I'm not sure. Admin will inform me what is the course fees. Right. But some of the candidates who are already working in industry, they don't want to undergo all this course. They want only TCL. So they can opt only for TCL. The same TCL is also covered in our course. Okay, now you can
okay,
ask
sir.
me what is your doubt?
Sir, I was asking that the TCL you will teach us in advanced TCLs and the TCL that are mentioned on your website, it's in a separate way. Both things are same, na sir? We will done the lab session also. There are 21, I think 21, 22 lab sessions are mentioned in your particular TCL course, sir. Like related to the file handling kind of things.
See, 100% those whatever videos are derived from here only. This is not a separate course what
Okay,
we have
sir.
done basic TCL. Those videos we have put by taking the videos from here only. That is 100% covered here.
Okay, sir.
Obviously, it is covered. Basic TCL is covered, and even advanced TCL is covered. See, even
Got it.
we cover advanced TCL, right? See, we teach TCL. See, we have also covered few videos in those courses, whatever you tell, which students have asked. See, even for example, while doing this advanced physical design course, if you ask some questions, sir, how to do this program, even I can teach that. So some of the topics may vary by asking by students questions. Apart from that, all topics remain same. Whatever you are going to learn there, the same thing you are going to learn here. Basic TCL is almost same. 99% it is same in TCL course and what you are learning here. Advanced TCL may little bit vary because it depends upon the student's question. Today, student come and ask me like how to get the HVT LVT cell count from the design. Then I'll cover. Student is asking, right? The mentor will cover. So what question student has asked during the TCL course there and here, based on that, 1 or 2 programs will change. Apart from that, 80% of syllabus remains same.
Okay, sir. Okay, understood, sir. Thank you, sir.
Now I'm going to know more regarding PD.
See, Verilog is like, see, physical design engineer doesn't want how to use RTL first of all. Total knowledge of RTL is not required. So we teach Verilog. I'm not telling that we are not going to teach what is Verilog. See, we teach Verilog on the netlist point of view, not on the RTL point of view. Because for physical design, netlist is important, not the RTL. So we teach netlist. If you so only that much is required. What is required for physical design we teach. But if you want to know RTL, like see RTL, if you go, you have procedural statement, you have non-procedural statement like assign statements and always block. In always block again you have blocking statement, non-blocking statement. So how to write the test benches? So all those things is not a part of physical design. So there is separate course for that. Like you have course for on top of that I mentioned right? Design verification or RTL design. So they cover the basics of RTL. That is not required for physical design. We are not going to cover for that reason. If you want that, then you can ask with admin like I want to undergo Verilog course, basic Verilog course. Then he may ask for nominal fees and you can enroll for. Oh, nominal fees it will be like 2,000 or 3,000. Apart from this, you can enroll for that. That is separate course, right? System Verilog comes under the category of what? Design verification. To do design verification, you want to know Verilog. One second, there's some problem with project that reconnected. Verilog, system Verilog, and UVM, Unified Verification Methodology. No, no, it's totally different. Design verification is separate tool. The course itself is totally different.
Hello, may I ask a question?
I'm not sure about verification. What's the tool name? I think Spyglass, something we use. I like, see, there is Cadence, we use NC Synopsys, I don't know which tool we use. Model sim we may use. Questa sim, model sim can be used. NC sim, Questa sim, model sim. Those are the simulator tools that can be used for design verification. Yes, sir. Please tell me any other doubts
Yes.
on the course.
Um, you have mentioned that the tools are used by the VPN. Is it any problem or problem with if someone is using from the outside India?
No, no problem. Right? We have given you the password, username and password. So you can only access if you know username and password.
So outside India is also fine.
Yes, yes. See, we have many students or many persons enrolled from even outside India. We have many persons from USA. They've enrolled, so they are using the VPN. They can use it.
Okay, thank you.
But I think they will be a little bit slow in the usage of tool. Probably it depends upon the country also.
Mhm.
But outside India also you can use a VPN. There is no restriction for that because we have already seen that they were already using.
Sure,
We have
sure.
many participants. I think they can use. So one more thing, the course is on both the modes. All right, like how now the students are attending. So students are attending course is on both modes. Is on both mode. Both mode means online and offline. Means few students are attending online now, and few are also in the institute offline. Same way, even course is going to happen. So Few students will attend online. We connect through GoToMeeting, and few will going to attend offline when they come to institute. Yes. Any other doubts you have? What course? 25. No, totally it's 25. Offline plus online is 25 per batch. If we have only means we should even give the tool, right? Tool should be used. See, basics, I think I don't know because I am not sure about basics. But advanced physical design is only 25 per batch, including online plus offline. Combining, it's only 25 per batch. Even 25 will not attend at a time, right? What the thing is, what we are doing here is we give them the recorded videos, live recorded videos. So most of them will depend on these recorded videos. They will not attend the classes itself because anyhow they are getting recorded videos. They will sit in the night and they will watch the videos. They will complete the. What do you mean? What's your doubt?
For weekend classes, for weekend daily classes, can I attend on my course completion?
See, you can do anything through after coming to VLSI Guru. You can come to VLSI Guru and you can do anything after course completion. There is no restriction. If you want to attend the theory classes even after the thing, right? I think there is no restriction because we have asked the students to enroll many times. Again, re-enroll. We have allowed that. But at least you should take a permission from the admin. You can attend the classes. See, our goal is to make you to get the job, not to make the money, right? When we make you to get the job, automatically the student enrollment will increase to make the business.
Hello, sir. I have one doubt. Hello.
Yes,
Hello,
please tell
sir.
me. Yes, please tell me.
Sir, currently I am choosing online course. If I am not okay with online class, can I come with offline?
There is no restriction on attending the classes. You can switch to any mode, anytime. You
Okay,
can
sir.
come. You can
Okay,
if
sir.
you feel you cannot come today, you can attend online. The link will be sent in the group. It is not sent to individually. Right? Sent in the group. You can attend online, and if you feel that you can come to offline, you can come to offline. There is no restriction in switching the mode. You can switch at any time. So you will come for offline for 5 days, 6 days. If you feel attend online, you will attend online. It's up to you. And you are attending online, and if you feel to come to institute, you can come to institute. There is no restriction in switching the mode. You can attend on any mode.
Okay, sir. Thank you, sir.
I have also answered to the placements, right? So see, currently the trend for placement is good for physical design, right? Currently it is good. The placement is good. See the placement, how it happens. See, I have seen the students, right? If any question is asked, they will take even more than 2 minutes to answer during the mock interviews. And if you're not serious about your course, so surely not get the placement. The student should be a little bit bright to handle the interviews. So if any question is asked like explain the ASIC design flow, so you should be going with the flow without non-stop because that is a basic question. So I am seeing even students will suffer to answer that. Like they will have some problem with even answering the basic questions. That is a case, right? Even your placement will affect even for many days till you get expert. Even you are expert in questions, so you will easily get the placement. There is no doubt in placements, right? Because see, there is two interviews for you every time. One is the service-based company who is going to recruit you is going to do the interview. Next is the product-based companies who is going to take give the project to you. Even he will do the interview. So every VLSI engineer will undergo two interviews in life. One is service-based company who is going to recruit you. with salary. He is going to do interview. Second interview happens with what? Client. So client is going to do the interview to you, right? So client interview is very important for you. So for that reason, if you're not good in communication, please start improving your communication skills, right? So not only communication, even your confidence level. How do you talk? With what confidence you're talking? It's also very important. So please start improving that. See, I am seeing the students are very good in doing the lab. I have handled many labs earlier. I'm seeing that students are very good in doing the lab. So they complete the projects on time. But if I ask any questions, right, we feel very difficult to answer them because probably they are not exposed to do the presentations, or they are not asked to do the means they are not asked to answer some Viva questions in UG classes. So for that reason, they feel very difficult to answer the questions. So that type of improvement I want the people to do in that aspect. Not only learning the lab or doing the lab on time is important. Even answering the question is very important. There are few questions which you have to answer in the bigger level, like explain ASIC design flow. At least it will take 2 minutes to explain. So you should be continuously talking for what? 2 minutes. Explain about yourself. I need not to teach you all these things. Explain about yourself. At least you should talk for 3 to 4 minutes about yourself. Right? About yourself should not tell you that my parents live in Andhra Pradesh and my father is some civil contract engineer. No, we don't want your family background. You want what skills you have, right? See, you should make a plan, right? If they ask me explain about yourself, what I should tell? I should tell first where I am from, with whom I am living. Like I have, see, we are living in Andhra Pradesh, and I was living with my parents till my degree, and now I have shifted to Bangalore to do the course. All right, this is fine. So next thing is stop answering your personal things. Second thing, suddenly skip to your skills, whatever skills you have, what you have learned. So what you learned in VLSI Guru, or what you learned in projects. So what motivated to you to do opt this career. So talk about the technical skills what you have. After technical skills, tell about your hobbies. What is your good hobbies? See, there should be even some good hobbies. Your hobbies should not be always like watching TV, listening to music. Even some good hobbies like playing cricket, reading books. All right, even that is also good hobbies, right? Or listening or playing music. Listening music is different. Playing music is different, right? So like playing music. Third thing is, all right, you can mention if you have got any awards. Like I have got award in. See, I was a cricket player and I have got district level award. You can mention that. So that you should close it after that. So this is my brief introduction. So this type of practice you should make before attending the interviews. So you should talk about 3 minutes about yourself, minimum 3 minutes. You cannot tell that I am Deepak, or I am Pratik, or I am some other person, and my parents live here and I am from Andhra Pradesh, and stop. That is not about yourself. You should tell about what technical skills you have, what you are good in, right? I am good in programming, I am good in handling the or say solving the difficult situations. So while doing the project, these type of situations I got and I fixed it by these methods. So I was having this type of, I was having 1000 shots and I fixed it by writing the TCL script. So all these things you can mention. What is how you good in what aspect you are good in. Right? Then you can mention your hobbies. Then you can mention your, if you have any awards or any things you have done, achievements you have done. You can mention that, and I can close your brief introduction. Not only with this, every concept which is taking 2 to 3 minutes to answer, you should be prepared for that. So I'm seeing that is not happening. Right? So all those things matters even to get the placement. It's not only VLSI Guru teaches, you attend the course, you do the lab, you will get the placement. It's not like that. Right? Even your personal development skills also matters. How do you handle the interview? See, handle the interview with a smiling face, with a bright face, not with nervousness or sad face. Right? So nervousness will be there. That is good. Right? That is okay. No issues. But you cannot handle the interviews with like uh, thinking for 2 minutes, not answering anything, silently sitting, telling wrong answers, whatever is there, arguing with the interviewer. So you should not do like that. So then your interview will clear. In one other second interview, it is going to clear for sure. So even apart from this course, you should also do the personal development. I'm telling in the beginning only, like improve your communication skills. If you're not good in English, right, try to improve your English at least to answer the questions for 2 to 3 minutes. To that level you improve, then you will obviously going to get the job. So now we will discuss on some technical aspects like what is physical design, why physical design, what are topics we are going to cover in physical design. Again, later you can ask me any doubts if you have on technical concept. Right? So to answer all this content, right? So I will start from here. What we do in physical design. So whatever we are learning VLSI courses is mainly to design what? Design IC. The IC has two things to do. One is design IC. You know IC, right? What is IC? Everyone know IC. Integrated
Yes.
circuit.
Circuit.
So IC has two things to do. One is design IC. One is fabricate IC. So fabrication of IC happens in where it's going to happen? Fabrication of IC. Yes, good. It's going to happen in semiconductor foundry. So you can name any one of the foundry. Yes, sir. TSMC. That's the biggest foundry. So most of the companies will depend on TSMC to get their IC fabricated. So Qualcomm, whatever ICs we are getting, it is only from TSMC. So Qualcomm also depends upon Samsung to fabricate their IC. So Samsung also has their own foundry to fabricate. Because anyhow, after fabricating the IC, Qualcomm is going to fabricate IC for your mobile phones. After fabricating IC, they are going to give their ICs for Samsung only. Samsung mobile phones only. But Samsung is having their own foundry again. So few ICs which are fabricated from Qualcomm is also going to Samsung, and few ICs of Qualcomm is fabricated from Samsung foundry. Whatever I calling foundry, right? Foundries are not a simple place. It is very highly sophisticated place to fabricate IC. Means this foundry should be minimum 1,000 times clean and neater than your ICU. Whatever you see, right? ICU in hospital or operation theater, what you see. So it should be 1,000 times cleaner and neater than what? ICU. Water should be very pure distilled water. And there should be many safety measures taken because fabrication IC happens in the chemical process. Right? So to open a foundry, there is a huge investment required. So more than it is in 1,000 crores to open IC. So India doesn't have sophisticated foundry. Even India has foundry, but not sophisticated foundry. Right? Means India doesn't have foundry to fabricate the ICs at the larger scale. So they can fabricate IC for research purpose, but they cannot fabricate IC for larger scale. Larger scale means to meet the market, time to market. So foundry, who are going to work in foundry? See, more than electronics engineers, the persons who are working in foundry is chemical engineers. Because fabricating IC happens through oxidation. So masking. So photo mask you will going to use, then etching. Etching means it is not like etching means removing some metal layer. Right? You have some metal layer or some oxide layer. Remove the oxide layer in this region. Or metal layer you remove in this region. How do you remove? You're not going to take the grinding machine and you're going to remove it in the foundry because it is happening in nanoscale. Nano means it's 10 to the power of -9. Even you cannot see through your eyes. So how do you do etching? Etching you will do by using chemical processor. Treat this thing with acid. This portion is going to melt away. That is called as etching. So every process, see, we will discuss that. What is a process in fabricating IC? we will discuss in CMOS basics in detail, right? So what I can tell is in foundry, more than electronics engineers, there is a need for chemical engineers to do all this process, to handle all these things. So, and they should be capable of handling their machineries, right? And handling the microscopes. So in foundry, we have majority, we have what? Chemical engineers. But one of the phases called as designing an IC. So designing an IC happens by using EDA tools. What is EDA? Electronic design automation tools. Now, can you tell me what do you mean by these EDA tools? See, EDA tools are software tools. See, by using these EDA tools, you are going to fabricate your IC. Or sorry, you're going to design your IC. You're not going to fabricate it. You're going to design your IC, right? So, what are the examples for EDA tools? You already used everyone. Most of them you have used Xilinx. Xilinx, Cadence, Synopsys. They are the vendors for to fabricate this or to design this EDA tools. So now, Xilinx you have already used. Even that is also used. Xilinx you have already used. Xilinx is a EDA tool to design FPGA. Similarly, you have EDA tools to design the ICs. Right. So generally to design an any IC, we use what? Electronic design automation tools. So for designing an IC, we have two major vendors. One is from Synopsys, another one is from Cadence, and even we have from Mentor Graphics. Mentor Graphics is not a very major vendor, but even we use tools from Mentor Graphics. So we are going to design an IC by using electronic design automation tools, means software tools. So for this reason, as we are using software tools, this software tools can easily understand TCL. You can understand Python. Tools can understand Python, but our PD tool can understand what? TCL. For that reason, we should understand how to use what? TCL. My tool, PD tool can understand only what? TCL. But it is good even if you know Python because you are handling doing file operations. You will dump 100 files. From 100 files, if you want to grab some information, for example, I have given you the 100 files. In that 100 files, if I ask you to get the clock skew from 100 files, what you should do? Open each file, find where is the clock skew, get the clock skew value. You should do 100 times, right? Open 100 files and do it manually if you do. Instead of write that, you can write the Python code, open the file, get the clock skew value and print it. So your Python only is going to do that. Python is not going to work on the tools. It's going to work on the files, which is generated from these tools. Tool will generate the files and we store it. So to use this file, to do operation on these files, we use what? Python. Even one of the important languages, Perl. Compared to TCL, Python and Perl has better packages to do the file operations. Right? So if you know Python and Perl is added advantage. You have added advantage if you know Python and Perl. You can become a CAD engineer. Right? But to do physical design, TCL is must. Why? Because I'm telling Python and Perl is optional. If you want, you can learn. But TCL is must. You should be knowing TCL. Because your EDA tool, whatever you use here, this is ICC2 or Fusion compiler or physical design. I'm writing only for physical design. So from Cadence we use Nose. So these tools can understand only what? TCL. So if I want to interact with tool, I should be knowing a TCL. So by using these tools, I am going to design an IC. After designing an IC, what information I should give to the foundry to fabricate my IC? What I give? We are designing team. Designing team is designing an IC. What information I will pass from design team to the fabricate team to fabricate IC? Hmm? Yes, good. Right? You are going to give a file called as GDS2 file. This file, the design team will give to what? Fabricating or foundry to design or fabricate the IC. Whatever this file we are giving, based on this only, the IC is going to fabricate. Then what is the content of this GDS2 file? Yes. Any other answers? What is the content of the GDS2 file?
It's a binary file.
Yes, it's a binary file, correct. Binary file means in a compiled format. We can't understand, but tool can understand.
It's a
Why
layout.
the industry? Yes, good. Right. It is a layout of cells. Right? Layout of cells. So you know what is layout then?
Yeah, I think they consist of different layers.
Yes. Can anyone tell me what is layout? It is a top view of your MOSFET. Right? If you take the MOSFET, see, actually, I will be having one good tool to draw everything, but okay, fine. I use this only now for time being. Right? Do you know what is MOSFET? Everyone know what is MOSFET? CMOS, you know? For CMOS, how the CMOS will be? Combination of NMOS and PMOS is called as what? CMOS. So this is your PMOS. At the bottom you have what? NMOS. This is a CMOS inverter. This is V out. This is what? V in. This is what? VDD. This is nothing but your CMOS inverter. So if you draw the CMOS inverter structure, what you find? You find a P substrate. What is this called as? P substrate. So in the P substrate, you are going to form what? You are going to form a N well. What is this? N well. Inside this N well, you are going to form. So P plus source, and here you are going to form what? N plus source and drain. This is N plus. This is P plus. What is this? N plus. So after this, what you have? Here you will be having what? Silicon dioxide. On top of that, you have what? Gate. You have gate here. So gate. This is your NMOS. This is your PMOS. Now, what you see from the top, right? That is something but called as what? Layout. So, top view of the 3D structure is called as what? Layout. Right? So, how to draw the layout? What is the layout you have? If you draw the layout for your CMOS, so first you have what? This P substrate. After P substrate, you will be having VDD and VSS rails. This is VDD. This is VSS rails. This is VDD. So any of this you are going to study in your lower class, CMOS classes, right? VDD and VSS rails you have. So after VDD and VSS rails, what you have? This VDD. This is VSS. Why I have given blue color? Blue color means it is a metal layer, right? So after that you have what? You have first you should draw the N well, correct? First you should draw the N well. So I am going to draw the N well. This N well. So inside N well what you have? P plus source and drain. So I will draw this P plus source and drain. So here also I will draw N plus source and drain. So in between I will cross by what? Polysilicon gate. So this is P plus, right? This is what? N plus. This is source. This is what? Drain. This is called as source and this is called as what? Drain. So your PMOS is formed in what? N well. This purple color is what? N well. Now you have to make the remaining connections. This source of your PMOS is connecting to what? VDD. So this P plus is a semiconductor, right? And this VDD is a metal layer. So by using metal layer, I will connect like this. So whenever your metal layer is connecting to the semiconductor, you have a contact cut formed. So here you have contact cut. Why there is a contact cut? Because this VDD is a metal layer and this green color is a P plus region. It is semiconductor. So here you are going to form what? One contact cut. Contact cut is nothing but some metal you are going to use to connect from there to here. Bottom you will be having semiconductor, top you will be having what? Metal. Resistance is going to change from semiconductor to what? Metal. Some contact cut you will do. And again, this source of your NMOS connecting where? To VSS. So connect this to VSS. Right? Again, you have one contact cut here. Right? Next, what is required? Your drain and drain has to be shorted. So short drain and drain. Okay. Short drain and drain. So you should short like this. This is a metal layer. So here you want contact cut, here you want contact, but here contact cut is not required because both are what? Both are metal layers. So now, what are the layers you are seeing here? This is metal. This is P plus. This is N plus. This is poly. Again, this is metal. This is N well. And this red color is this outer boundary is P substrate. Now again one more connection is required, right? So one is nothing but so here I want to make a connection. This is the basic structure of your layout. Again you want a contact cut here because it's a polysilicon and you're making connection with what? You're making connection with semiconductor. So again you want one contact cut here. This is a layout of your inverter. So for example, this inverter is connecting to one AND gate. Output of AND gate is connecting to what? Inverter. You will be having layout of AND gate. The layout of AND output connect to what? The input of your output of AND gate connect to input of the inverter. So output of inverter connect to the another gate. So even you will be having layout of another gate here. So like that connection of layout is called as what? Connection of layout is called as GDS file. So I talked about GDS file. Connection of layout is called as what? GDS file. So this layout information will pass to foundry, semiconductor foundry to get the IC fabricated. So now how to get this GDS file? So that process we will discuss in the second half. We'll take a break now. Now time is 10:55. Right? 10 minutes break we take. Till 11:10 we'll take the break. We will continue after the break. So in this aspect, I'll discuss why physical design, what we do in physical design, what topic is covered. Right? So now you understood what is GDS file. What is GDS file? It's a layout. Connection of layouts is called as what? GDS file. That information we pass to what? Foundry, and foundry is going to fabricate IC for us based on the GDS. If any problem happens in the IC, who is responsible? Design team is responsible. Foundry will never take the responsibility. So we should design in such a way that this design is never going to fail. Take a break now. We'll continue at 11. Okay, we'll continue now again. So I discussed about this, right? So at last the design team should give what? GDS file to the semiconductor foundry to fabricate the IC. So then what is physical design? What we do in physical design? To understand this, so we should little bit go into the process of ASIC design flow. So how many of you know this ASIC design flow? If you know, it is good. Right? Please listen to this. It will be a little bit different, not be the same. Right? So ASIC design flow first starts with specification. Specification of IC means specification of IC means what is IC, right? What is the content of IC? See, IC has this is IC, right? Total IC. In this IC, what are the blocks required? So you want ALU block, or you want a RISC core processor, you want a clocking module, you want Ethernet module. So what are the modules you want in IC? Right? And each module is working with what clock frequency, estimated clock frequency, with what clock frequency they have to work. Right? What is the power consumption? What is the maximum power consumption? What is the total size of an IC? What can be the total size? So all these things they will discuss with the vendor, right? And they will, or that, for example, here the vendor is the, for example, Qualcomm is fabricating IC means who is a vendor? Vendor is nothing but mobile phone manufacturer, right? So who is going to purchase the ICs of Qualcomm? Mobile phone manufacturers like Redmi, your Samsung. So all these persons are going to fabricate. So then this person Qualcomm who is going to fabricate IC, he has to make some decision like what should be the blocks should be present in my IC, what blocks I should use. Each block should work on what clock frequency, what is the area, what is the size of the IC. All this specification he should give to the mobile phone manufacturer. Mobile phone manufacturer here is a client, right? And Qualcomm is a person who is going to give the IC for the mobile phone manufacturer. So in specification of IC here, internal blocks, clock frequency, estimated power, estimated area. All these are given to the clients. So this is what we can achieve. And now the client tells that I don't want only this much. I want a little bit extra camera feature. My camera should be very good. Then they have to add some new CCD in the camera controller module blocks. So all those things they have to include and they have to create a new specification. So after creating specification, so what we do? The next step, start design, right? Design entry. Start doing the design of what are the blocks you have. So start doing the design of what? Ethernet module. Start doing the design of RISC core processor. So start doing the design. So here design entry happens through RTL. RTL means Verilog or VHDL code is used. We use Verilog or VHDL code define a circuit. So why we should use Verilog or VHDL? Why I cannot directly write the circuit? Why I should use Verilog or VHDL? Why I cannot directly write the circuit? Now, why they have introduced this programming as one of the part in the flow, right? They can directly write the circuit. Why they have introduced the programming languages like this Varilla or VHDL? Why they have included it? Hardware programming languages, hardware description language. Why we have
So
to
that
describe the hardware by using these languages? Why we have to do that?
for simulation,
Simulation we are doing because we are describing through these languages. Whether this whatever we have defined by using this language is proper or not. To verify that we do simulation.
This is for the programming of the hardware, like how it does work.
Yes, my question is why we have to program by using Verilog or VHDL?
so that if anything goes wrong, first we have to verify it. It is better to verify on software rather than.
Okay, I'll give you one example now. So now everyone understood what is layout, right?
Yes.
I'll try open one more thing. Opening the same thing. Okay, now you take that I have one mux. Just I'll take a for example, I will take 2:1 mux. This is I naught, this is I1, this is Y, this is 2:1 mux. Now this select line. So if I ask what is the internal structure of mux by using gates, how many can you write? I am asking internal structure you write by using gates, basic gates. What are basic gates? And OR gate, inverter. By using that, write the structure of mux. How many can you write? Okay, hear about that question. Tell me the operation of this mux. How many can you tell? You have select line and you have Y. What is the operation of mux?
Based on the select, it selects either I0 or I1.
Yes, when select line is 0, Y is taking what? I0. When select line is 1, Y is going to take what? I1. So describing the behavior of mux is easy, but describing its internal circuit is difficult, right? D flip flop. If I ask, how many will define the internal? What is the role of D flip flop? You have reset pin. You have Q bar I. So what is the role of D flip flop? Whatever is present on D, it will pass to Q when you get positive edge of clock. If I ask you to describe the internal structure of D flip flop, will you describe? Or internal structure you can write by using gates. But if I tell write a truth table, yes, you can write it right. When reset is 1, what is Q? Q is always 0. When reset is 0, your Q is going to take what? D value at positive edge of clock. Whatever is present on D, it's going to pass to what? Q at positive edge of clock. This is the structure of, or this is a behavior of your D flip flop. This is a behavior of your mux. So truth table you have written in your UG classes. That's nothing but what behavior of your circuit, right? So defining any circuit through its behavior is easy, but defining through its internal structure is difficult. So the programming languages, whatever we have defined, we will describe every design through its behavior. Right? I can define this mux by using if statement easily, right? If yes equals 0, assign y is equal to what? I naught. Else assign y is equal to I1. So this behavior I have described through what? This behavior I have described through the programming language. Right? Here also I can discuss. always at positive edge of clock. Always at positive edge of clock. If the reset is synchronous, right? If reset is equal to 1, what is Q? 0, else Q is assigned with what? Q is equal to D. I have defined D flip flop. So I am defining the behavior of D flip flop, not the internal structure. So defining any behavior of a circuit is very easy compared to internal structure. For that reason, what we do is we use what? We will do design entry by using what? RTL. That is by using Verilog or VHDL code. So here circuit is defined. Circuit is defined based on behavior of based on the behavior. So behavior modeling is going to help you to use if statement, case statements. So by using that, you can define the circuit easily, which I have already done here, right? So for that reason, we do design entry by using what? RTL. So next is, what is the third thing? Third step, design verification. Next step is design verification. So design verification is also called as functional verification. So what is this functional verification? What we do in functional verification? See, I told you this is one of the course, right? Here, you can remember that. So what we do in the functional verification or design verification? So I have described my design by using what? Verilog or VHDL. I have to verify that whether this Verilog or VHDL is going to implement the intended functionality or not. Right? Means I have written the program for MUX. Whether this program is working like MUX or not, I have to verify. How to verify? Apply the different inputs, right? Apply 0, 0, 0. This is I0, this is I1, this select line. So 0, 0, 0. What is your expected output? If select line is 0, output should take what? I0. What is I0? I0 is 0. Apply 0, 1, 0, 1. What do you want here? 0, 1, 1, 1, 1. So apply different. This is called as test vector. This is called as what? Test vector. So apply the test vectors or test cases and verify what is the output. If you are getting intended output, what is required, then your Verilog is implementing the required functionality. Or else you're not implementing the required functionality. You have to check your Verilog program again. Okay? That you will do in design verification or functional verification. So, what is functional verification? Verifying functionality of design by applying test cases. What is test cases? This is test case. Right? This is test case. So it is not so simple. Just because whatever the design I'm discussing here is having only 3 inputs. Generally, the bigger design has, say, 3 inputs means how many combinations you will get here? 0, 0, 0, 0, 0, 1, 0, 1, 0. Totally you will get what? 8 combinations means 2 power 3. If I have 100 inputs, then how many input combinations I have? 2 power 100. Then it's almost more than 1 lakh combinations. I cannot apply all these 1 lakh combinations to test. So I should gently and using intelligence, I should decide which combination I have to use to test the circuit. Functional coverage to be met while doing this test. So for that reason, what the people will do is you will learn few techniques here like UVM, how to do design verification for bigger circuits. You will learn UVM, Unified Universal Verification methodology. So in this case, you should be knowing mainly Verilog, and system Verilog. So this is only verifying the design, but design is in the what form? Design is in the what form? RTL. So RTL has the design in the behavioral form. Correct? Okay, next is right. What is the next thing you have? So after design verification, you have what? Synthesis. What is synthesis? Verifying. What is synthesis? See, now design is in the what form? Design is in the behavioral form. So behavioral form your foundry cannot understand. Foundry can understand only what foundry can understand. Foundry can understand only the TDS, means layout you can understand. So first from behavior you have to convert to the gate level form. That is called as what? Synthesis. Gate level form convert to the layout form. That is called as what? Physical design. So first the next step is this behavioral form convert to gate level form. That is called as synthesis. So what is synthesis? Yes, correct. So synthesis is nothing but converting your RTL is already in the behavioral form to gate level netlist. I'll tell you what is netlist later. This is called as what? Synthesis. Convert your RTL to gate level netlist. So now I am converting this behavioral description into gate level netlist. I want this gate level information. So who is going to give this gate level information? Next question. So you have to understand this. I am converting RTL to gate level netlist, right? So gate level netlist has gates. So what gates I have to use to convert this RTL to gate level netlist? What are the gates I have to use? So I am doing the classes for you people. Admin told me to do the classes for you people. So admin has told this. Similarly, RTL should be converted to gate level. So after converting gate level, I'll be having gates. Then what gates I have to use? Yes, right. So we have there is a file called as. So next we'll discuss inputs for synthesis. So for input for synthesis, I'm saying, but one is your RTL. Right? That only you're converting to what? Gate level netlist. So RTL, the design is in the BL form. So next is what? You have. library file, library, or it's called as what? Liberty file. It is called as .lib. So third thing is HTC. So these three things are very much important to do what? Converting RTL to gate level netlist. You know what is RTL consists of? It has behavioral description of the design. So Liberty file is nothing but it has gate information, or I can tell standard cell information. It has standard cells information. So standard
Hi,
cells
sir.
means there are few
Hi.
cells called as some cells,
Uh,
right? Like
Hi.
and
Sorry for interrupt. Actually, this all
yes,
are
yes.
input given by customer or clients, or we'll extract from our
The
design.
RTL you are writing it. Right? Your
Okay.
design team is going to write the RTL. So Liberty file
Okay.
will get from the PDK development team. There is a PDK
Okay.
development team or cell characterization team. That is a full custom design. That is not a see what we are doing here is a semi-custom design, because we are not starting the
Okay.
design from the scratch. Means we are not starting from the transistor level. You directly entering into what level? From behavioral, you're directly going into what? Gate level. There is one team called as full custom design team or library characterization team. It's also called as PDK development team. So they will give this .lib file. So they will get the spice level circuits from the foundry. Foundry will give spice level circuits for PDK team, and that PDK team is going to create this library file. PDK team is also called as PDK means process development kit. Right? PDK team, or it's also called as library characterization team. So they are going to give this. So you have standard cell information. So standard cell informations are like AND gate, OR gate, NOR gate, inverter, buffer, half adder, full adder, mux, flip flop. So all these are called as what? Standard cells. In some basic cells, basic gates required to implement the bigger designs. So there can be some AOI gate and or invert, or OAI gate and or and invert. So these are some gates. For these gates, you will be having information in which file? Liberty file or library file. What information you will be having? You will be having timing, functionality, area. What is area of the layout of these cells? How much area these cells are taking? Layout area, timing. Timing means the cell delay. What is the cell delay of these cells? Then power. What is the power consumption of these cells? So this information will be seen in Liberty file. So in the advanced PDF classes, you will open this Liberty file. First, you will understand this file. What is the content of this file? Right. So next is, but we will use these cells which is mentioned in Liberty file to form what? Gate level netlist. So next we have HTC. HTC stands for Synopsys Design Constraints. So what is Synopsys design constraint? See, I am converting my RTL to gate level. Okay, fine. But I cannot I cannot see conversion RTL to gate level is very easy if there is no constraint. But if there is a constraint, it's very difficult. Constraint means the clock frequency. What is clock period? And you should use, synopsis design constraint as what is the clock period, what is the maximum power consumption. So that this constraint you should give to the tool. So your tool should do the conversion from RTL to gate level netlist by meeting what? This clock period. Your design should work with this clock period and it should consume only this much power. This constraint you should give to the tool. See, if your father tells that, or your any person who is going to, so when there is no economic restriction to you, and your father tells that go to VLSI Guru and come back with whatever modes you want, it's very easy. Book a cab, the cab will come to your home, he will pick you, you will come here and you'll go back. It's very easy. And if your father tells that go to VLSI Guru and come back by using 20 rupees, then it's difficult task. Walk for some distance, get the bus, come here and go back. That is called as constraint. So if you put the constraint, then the conversion becomes very difficult. So tool has to run many iterations, do the modification, do the logical restructuring, do the modification so that my design is going to work with this clock period and this much power consumption. See, HDC doesn't have only clock period and power consumption information. You have some other commands like set driving cell, set input delay, set output delay, set load. All these things you are going to learn in the future classes. So what is the content of HTC? But time being, you understand this much only. So after giving all this information, your tool is going to convert your RTL to what? Gate level netlist. So by picking the cells present in what file? Picking the cells present in Liberty file or library file. So after conversion, your design is in the gate level form. Then what is output of synthesis? What is output of synthesis?
Gate level netlist.
Gate level netlist. Very good, right? So what is a gate level netlist then? What the gate level netlist has then? The gate level netlist should have only gate and its connections. It should not be having any other information. It should be having only gate and its connection. See, I just write the gate level netlist, right? Just to understanding purpose. One more point because all those information I want again. For example, you imagine that I have one smaller circuit. Simplicity, I'll take one smaller circuit like this. So which is having 3 ports. B, C. What is this? A, B, C. This AB is connecting to one OR gate. This A1 pin, this A2 pin, this Y pin. This output is connecting to one AND gate, A1 pin. In another input is A2 pin, Y pin, and this is connecting to one inverter. This A pin and this Y pin of inverter, and it's going to the output, and this output is nothing but some M. Output port name is M. So this is a gate level diagram. Then what do you mean by gate level netlist? So even gate level netlist is also a Verilog program. What is that? It's also Verilog or VSTL program, but your RTL is in the behavioral form, but gate level netlist is in the structural form. See, this gate level netlist should have only gate and its connection. Apart from that, it should not be having any other command. Like if statement should not be there, case statement should not be there. No assign command should be there. Only it should be having gate and its connections. So I'll write the gate level netlist now. So what is a gate level netlist as? Verilog as first we will be having module and module name. Module name I call it as some temp, some random name I use. What are the inputs? A comma. See, already I'm using the port name as A. Instead of A, I use, because here port name is A, right? Instead of A, I use some X. What is inputs? X, B, C, sorry, comma, output is M. So I should declare the inputs, right? Inputs are X, B, C, output is M. So these are the intermediate wires. This I'll call it as N1 wire. This I'll call it as N2 wire. This even wire I have to declare. Wire N1 comma N2. This is normal in your case of RTL and here. Next, in RTL you can use if statements, anything, or you can write a Boolean expression for this. But in case of gate level netlist, you should be having gate and its connections. That's self. So this OR gate name is R2 in your library file, Liberty file you have, right? In that file, this OR gate name is what? R2 means 2 input OR gate. This name is AND 2. This name is inverter, INV. So first I have to declare this cell. So what is the first cell? R2. So my synthesis tool will give one instance name. Instance name is what? U1. Because this name, because in the design I can be having one more OR gate. I can be having one more OR gate. So all the OR gate name is same, R2. Because this is a name from what? Liberty file. So I have to have some description, or I should be having some difference between one OR gate to another OR gate. So for that reason, what my tool will do, synthesis tool, it is going to give one instance name. This instance name is different for different cells. For this cell it is U1, for this cell it is U2, this cell it is what? U3. This is given by my synthesis tool by default. So first I will be having the library cell name, then the instance name, then port mapping. Port mapping means for A1 pin of this OR gate, what is connecting? For A1 pin, what is connecting? X input is connecting, comma. For B pin, so there is no B pin. Instead of B pin, what is present? A2 pin. Dot A2 pin. For A2 pin, what is connecting? B input is connecting, comma. Dot Y. Y pin of your OR gate, what is connecting? N1 net is connecting. Next, describe the second cell. What is that? And 2. Instance name is U2. This is given by my synthesis tool. So dot A1. So A1 pin, where it's connecting? It's connecting to N1 net, comma, dot A2, where it's connecting? C. Dot Y, where it's connecting? N2. Next, I have only one inverter, INV U3. Dot A, where it's connecting to N2. Dot Y, where it's connecting? M port. N module. So only this information should be present in the netlist. Here you have gates in information and its connection. See, connection is maintained here, right? Whether connection is there or not. See, here N1 is output of Y pin, right? This N1 net is connecting to what? Y pin of this OR gate, right? And here the same N1 is connecting to what? A1 pin of AND gate. So here connection is established. My tool can understand this connection. Here N1 is connecting to Y pin, means output pin of OR gate. Same N1 is connecting to input pin of AND gate, means the meaning is what? The output of OR gate is connecting to what? Input of AND gate. So connection is established. So here also connection is established. So this is called as gate and its connections. So that is present in what? Gate level netlist. So only should be having gate level, gate and its connections. Apart from that, no if statement, no case statement, no assign statement, no Boolean expression, nothing is allowed. Only this should be present in the gate level netlist. Yes, sir. So after synthesis, I will get this gate level netlist. So now my design is in what form? Now my design is in what form? Now my design is in what form? Synthesis, after synthesis.
Gate
Now
level.
my design is in gate level form. Right? So this gate level form. From behavioral, we converted to what? Gate level. Even this gate level, my foundry can understand. My foundry can understand what? Only where I discussed that here, right? Yes. My foundry can understand only CDS has got only layout of cells. So the role of physical design engineers. So here one more team will come into picture, that is called as a DFT team. During synthesis only, there is one more team will come into picture, DFT team. So it is for design for testability. Can anyone tell me what is their role? It is one of the separate course. No, I want clear information what the team will do.
Maybe
After IC is fabricated, I have fabricated the IC. Foundry has fabricated IC. Now, whether this IC during fabrication, there is a chance that one metal layer is fabricated like this because it's in nanoscale. It's not in the centimeter scale. One metal layer, there is a chance that it may be fabricated like this. So internally they are shorted. Actually, I want like this, two metal layers. But internally they are what? Shorted. Because my during etching, the foundry has not etched properly. So they slightly it is shorting because it is a chemical driven process. So they not grind by taking grinding machine. The chemical has to etch it or acid has to remove it. So here acid has not removed it. So now there is a short. This short will never allow my IC to work properly. So after fabricating, I cannot tell that my IC is working properly. I have to test my IC. How to test IC? Apply some test input. Verify the test output. Whatever test input you are applying, whatever test output you are getting, it is same as compared to what? Functional verification. Yeah, you do functional verification, right? This result and this result both are same. Then your IC is working properly. See, we are testing when the IC is fabricated. We are not testing. See, here we test during what? During in the software tool. This test happens in software tool. Whatever result we get, we store it. So the same test cases we apply after what? IC is fabricated. If both results are same, then it is going to match. So I am telling in a simple form, but actually that process is called as automatic test pattern generation, ATPG. So your DFT team is going to work on ATPG to capture the test results. So in that software, they are going to capture the test result. Those test results they will go give to what? They'll give to a team called as post silicon validation team. There's a team called as what? Post silicon validation team. What is the meaning of post silicon validation? After IC is fabricated, apply the test case. Right? After IC is fabricated, apply the test case, verify what is output, and compare this output with what. So what is the output what we get in design verification stage? If both are matching, my IC is working properly. If both are not matching, my IC is not working properly. Right? So this testing is done by a team called as what? Post silicon validation team. Your DFT team is not going to test that. Who is going to test that? Post silicon validation team. So your IC, if I apply the test cases, right? Your IC should take these test cases to apply this test cases into this IC and to get the design or the test cases output from the output ports, right? So my design for testability team, they will do some small modification in the gate level netlist. So why they will do modification? I can easily pass the test cases inside the IC and I can get the results from the IC. So to do that, what they will do, they will do modification in what? Gate level netlist. In here, this gate level netlist only is going to convert into what form? Layout form. So design for testability team, they will do modification, right? They will do modification in gate level netlist so that it can be tested after fabrication. So testing the chip after fabrication is called as what? Post silicon validation. So to make this process easy, right? Testing the chip after fabrication. To make this process easy, your design for testability team, they are going to modify the gate level netlist. But this modification should not affect your functionality in such a way that they are going to modify it. So I'm not going to teach what DFT is going to do because it's not part of the PD team or even synthesis team. There is a separate course on DFT. There is a separate team. So what the DFT will do is just I'll mention what they will do. They will do like scan chain insertion. MBIST. MBIST means memory built-in self-test. They will do boundary scanning. So automatic test pattern generation. All these things you have to learn in your DFT course, automatic test pattern generation. After modifying some part of gate level netlist without affecting functionality, this gate level netlist they will give to what? Physical design team. So gate level netlist, the design is present in what form? Gate level form. This gate level form your foundry cannot understand. So you have to convert this into layout form. Right? So that is the role of physical design engineers. So next step is, fourth important step is physical design. So now I have one small question here. So this is the role of a physical design team. Right? So now my question is whether we are going to draw the layout. Whether a physical design team is going to draw the layout. See what I want to tell is we have to convert all this. So I'll tell you what is the role of physical design engineers first. Alright. The role of physical design engineers is, so I have the netlist. Alright. So for this netlist, based on the netlist, I have to create what? Core area and die area. So first step in physical design is, right, floor planning. So floor planning, right? In this floor planning, the first step goes with, right, creating core area and die area. So I have to create this core area and die area. So after creating core area and die area, right? So the design ports, if I have any ports, I have to place the ports in between core area and die area. So ports are nothing but here you see the ports here, right? What are the ports here? X, B, C is a port and M is a port. Is a input port, these are output port. So if I have any port, that port here it is in the text format. This we call it as a logical form. Text format is called as what? Logical form. Physical form is nothing but metal layer, right? I have to place here by using metal layers. So place input and output ports. After placing ports, right? Then I should do some. So next step is what? Port placement. Port step is macro placement. If you have any, see, if you have any complex cells in the design apart from the standard cells, so which you need not to do this all the steps. Already you have some complex cells. I'll tell you one example, right? You ask your mother to prepare some dish, right? She will prepare everything from the scratch, right? Like writing Verilog code. It's called as scratch. But some dish can be directly done. She wanted to do from the directly. She wanted to do everything from the scratch. For example, she wanted to do puliogre, right? She can directly purchase a puliogre powder from what? From the shop. She needed to do direct everything from the scratch. So even like that, right? Whether if we have some designs where the layout is already available, so your design wants some risk core processor. So risk core processor layout is already available. Layout is available. So why I have to write the Verilog code? Why I have to do synthesis? Directly use the layout, right? Directly use the layout here. Directly use a layout of what? Risk core processor, which is already available in the market. You directly purchase the layout and directly use the layout here. So for this, you are not writing the Verilog code, you are not doing the synthesis. Directly you are purchasing from the vendor, you are going to place the layout here. So these are called as what? Macros. So what are macros? Macros are complex cells. Complex cells which are already optimized. Optimized means I can tell that, see, why you are going to purchase the puligra powder from the shop? Because you feel that, or your mother feels that that is the best quality or that is the best taste. Even if you prepare, you cannot get the taste. Then only you will purchase, right? The same reason here also, right? We are going to purchase macro from some other vendor because that macro is working very good. It's having very good timing, power, and area capability. Then only we purchase. So if you have any circuits like that, then first place those circuits in the design. Right? Macros are what? It's a complex cells which are already optimized. So place the macros. See, generally in the design, in the industry, you are going to work in the design which is having 10 to 40 lakhs standard cells. You will be having 10 to 40 lakhs standard cells. How many standard cells have written here? 1 to 3. But in the real design, in the real industry design, you will be having how many cells? It can range between 10 to 40 lakhs. If you have 10 to 40 lakhs, then you have 40 to 50 macros. 40 to 50 macros means 40 to 50 complex cells, which you need not to do from the scratch. Already directly you can use the layout of this cells. Right? So like that, first do macro placement first. All these are macros. Macros are bigger designs, right? First do the macro placement. So after doing macro placement, this do the macro placement first. So after doing macro placement, next you should see next you should do power planning. Means power planning means if you see the layout which I have already drawn, every cell requires what? Every cell requires VDD and VSS connections, correct? VDD and VSS connections. All the 40 lakh cells, including macros, requires what? VDD and VSS connections. So I have to give the connections to all these cells without IR drop. What is IR drop? I have one cell here. I have VDD port here. This VDD port is having like 1.5 volts as VDD. See, VDD value is very less here. VDD value is not like your UG classes, what you have learned, 5 volts or 2.5 volts. So because we are working in lower technology, when the dimension is scaling down, even voltage is also scaling down. So VDD values itself is 1.5 volts. So I want connection from here to here. Out of 1.5 volt, only 1.2 volt is going to reach to my cell. Remaining voltage drop is going to happen on this metal layer. 0.3 volt drop is going to happen on the metal layer, because metal layer is going to have resistance. In this metal layer, current is going to draw, current is going to flow. According to Ohm's law, I into R is going to Q what? V. So because of the resistance present in this metal layer, some voltage drop is going to happen on the metal layer. That voltage drop is going to convert in the form of what? Heat. That is lost in the form of what? Heat. So how much is going to reach here? 1.2 volt. So now my cell performance is affected. Performance means cell delay. Cell delay is going to increase if I get less VDD. So whatever I am applying here, 1.5 volts, the same 1.5 volts should reach here. So I should be having less IR drop. This IR drop has to be totally reduced. So then how to do the power planning to reduce this IR drop? That we are going to see. Right? So after doing floor planning, we are going to do placement of standard cells. What is placement of standard cells? All 40 lakh cells what you have here, right? All these cells you should place in the core area, right? All the cells you start placing in core area. So what is this? This is layout of cells. It is not a normal cell. It's what? It is a layout of a cell. You place inside what? Core area. Only cells we are placing. Right? So now my question is whether we are going to draw the layout. Physical design engineers. This is a layout of AND gate. Whether I have drawn the layout of AND gate in any of the flow here? No, I am not going to draw the layout. Physical design engineers is not going to draw the layout. It is drawn from the layout team. That layout team is going to give us in the form of file called as LEF file. Layout exchange format file. This file has layout information of all the standard cells. So I am going to use so in the netlist I have OR gate. For this OR gate, the layout is present in which file? LEF file. So I am going to use the layout of that file and I am going to place in what? I am going to place inside the core area. So place all 40 to 50 lakh cells inside the core area. So to placing 40 to 50 lakh cells or 10 to 40 lakh cells inside the core area, it is going to take 3 days. There is one command, place out. This command, to run this command, it's going to take 3 days. You don't have any other work to do. The command only will run for what? 3 days. Because it has to place all these cells inside the core area. This placing itself will take 2 days or 3 days. Because you are working in lax together cells. If you have only 10 cells, right, you can do it in 2 seconds. But 40 lakh cells, it's going to take 2 days or 3 days. So you should never do any mistake while doing macro placement, port placement, or placement of standard cells. So after placement of standard cells, we do clock tree synthesis. Next, we do what? Routing. Routing. Whatever standard cells I have, right? I have to connect by using what? Metal layers. I have to make the connections. Make these connections. by using metal layers. That is called as what? Routing. See what is the connection present here? So N1 net output of OR gate is connecting to what? Input of AND gate. So here also you do the connection here. Output of OR gate. Okay, OR gate is here. Connect to input of what? AND gate by using what? Metal layer. That is called as what? Routing. After routing, we do sign off checks. In sign off checks, we do timing check. We do checks like DRC, right? LBS. We do power and IR drop check. All this timing sign, all this sign off checks we do. When this my design is passing the timing sign off checks, then we'll create what? At last we create TDS2 file and send to foundry. Whatever steps I have discussed here, it is not that much easy. You have a lot of things to learn. So now this part we are doing it. This is called as physical design, means converting your gate level netlist to what? Layout form. So here what you are placing? You are placing standard cells layout, right? And macros layout and connect by using what? Metal layers. So for this design, you create what? GDS file and send to what? Foundry. This is the role of physical design engineers. Now, then what you are going to learn in this course? Course content. See, for this, we are going to do both, right? Lab as well as theory. So first, we start discussing about what is full chip level design and block level design. Next, we discuss about what is input files for physical design. So I discussed input files for synthesis, right? So next, similarly, we discuss input files for what? Input files for physical design. See, input file is not like simply mentioning like this. You will open the input files and check what is present in that. So it is like live, hands-on. It is not a theory part. Theory is done in the theory classes. In the lab class, you will see what are the real input files. So after input files, next you will do what? Floor planning. So this is block level floor planning, not full chip level floor planning. So we do block level design. So block level floor planning, because at the beginning all the freshers will work on block level itself. So you will work on the full chip level only after 6 to 7 years of experience. So we'll mainly focus on what? Block level floor planning. So floor planning consists of what? All these things. So in this block level floor planning, we will also discuss about a few other aspects. What is that? Nothing but multi-voltage design, power reduction techniques, right? See, every step is discussed. See, creating core-reliant die area. On what factors you can create core-reliant die area? So, who is going to create core-reliant die area for full chip and block level design? Port placement. What are the rules for port placement? What are the rules for macro placement? So, if you want to do power planning, how to do power planning? So, theory we discuss. Similarly, we do the same thing in the lab. Alright. So, multi-voltage design means, what do you mean by multi-voltage design? What is the how to write the constraints for multi-voltage design? So what are different power reduction techniques? So all those things we discuss in block level floor planning. So next we discuss on Fourth thing, STA, static timing analysis. Static timing analysis, we discuss again on what is clock, clock period, Q, jitter, uncertainty. So setup and hold analysis. Pulse path and multi-cycle path. QT conditions. So we discuss again on MCMM file, multi-mode, multi-corner file. Seventh, to handle asynchronous signals. All these things we cover in what? STA. So after STA, we go with placement. So placement, we discuss this placement of standard cells, right? All the standard cells has to be placed inside. So what is the commands for doing placement? So what is the best placement method? So what is the place after placement? What are the reports you will generate? So if there is any violation in placement, like congestion is not met, or you are having any DRV violations, so how to fix the issues? So everything is discussed in placement stage. So next we discuss on CTS in detail, clock tree synthesis. So what are methods of doing clock tree synthesis? What is clock tree specification file? So what do we mean by latency? What do we mean by skew? How to reduce skew and latency? So how to reduce the hold violations, especially after CTS. So if you have any setup violation, how to reduce it? So all those things we discuss in CTS. So after CTS, and next you have is what? Routing. So in the routing, we discuss about routing issues. If you have any shorts, opens, if you are having any DRC violations, you are having anything like called as LDS violations, then how to fix all these things. So we discuss in routing and its issues. After routing, we discuss on sign-off checks. So there are three types of sign-off checks. So one is timing sign-off, power sign-off, next is physical verification. So all these things, timing sign-off checks will do. So this is what we cover in our course. So you will do the two projects in the lab. So one project you will do with help of mentor. Other project you should do by your own. Mentor, with help of mentor means mentor will teach you everything step by step. How to do the lab. So how to create covalent area, what is the command, how to understand the command, what is how to get the command from the tool, everything from the tool installation till the sign off checks. So the mentor will help you in step by step process for one project. Another project you have to do by your own. So if you have any doubts, you can contact every student is created with individual WhatsApp group. So you will be present in the main WhatsApp group where all the students will be present, including the owner, admin team, office team, manager team, everything will be present. Apart from that, every student will be having individual WhatsApp group. Individual WhatsApp group means you will be present. Apart from you, no one will be present. You will be present, owner will be present, admin office team will be present, and a trainer will be present. So if you have any doubts, you can post in the individual WhatsApp group. For every student, it's created. So you can post any queries. You can post in the individual WhatsApp group. You have one more WhatsApp group called as all students will be present. That group is only to post a schedule. See, we cannot post a schedule for each and every student separately. Schedule means at what time the classes for this week. It is fixed almost, but in spite of that, admin will message every week. This time, this is a class. So there is a chance that sometimes your weekend classes may get rescheduled because the trainer is not available. He has some important project to be handled. So anything like that, they will notify you. Or you are having any holidays, like you are having holiday for Yugati, they will notify you in that group. Apart from that, you have individual WhatsApp group. If you have any queries, you can message in that. Yes, sir. Now you can ask me if you have any doubts. I'll stop here. If you have any doubts,
Uh,
you can ask me.
Hello,
Yes, tell
hello.
me.
Hi, sir.
Yes, please tell me.
Sir, I have one doubt. That is actually right now I am doing some internship in some company, and in that company, my role is related to system architecture. Okay, hello.
Yes, yes, please tell me.
Uh, but I wanted to shift towards the physical design side. But the problem is that I don't want to leave that company because it's a product-based company and they offer me a very good package in system architecture modeling. So what should I do? Give me a like best solution for that problem.
So, system architecture, what role you're doing there?
In that system architecture, I am using the Synopsys Platform Architect tool, and there is one team who is designing the architecture for that chip, and we are going to optimize the architecture of that chip by using the virtual prototype of that architecture on the Synopsys Platform Architect tool. So basically, this is based on cycle accurate model, like how much we reduce the delay when my chip will fabricate, then how much it will work fast. That kind of work is there in my role.
See, you learn the concept and you can tell to your company that you are good in this. They may shift you to that this role also, physical design also.
No, but they offer me only the PPO on that system architecture role. I discuss with these things with my mentor, but he tell me you got offer only on this role. If you want physical design, then I will not do anything. So should I leave the company or prepare for the physical design or what?
This I am not sure because I don't know what is the package you're getting. Like, if it is very good, then you stay back, right? Why you want to leave it?
Yeah, its package is very good, sir. Like the offer, like
There
Qualcomm
are
and
few
Intel.
roles. There are few roles where there is some they will lay off immediately because that role is very easy. So few roles which is very difficult. They cannot lay off the engineers because getting the engineers letter is very difficult. So your role is dependent on what factor. Like is very easy role. Like
No,
you are
it's
doing the
not.
same work again and again.
Sir, architecture role is not a easy role. It's a very difficult role, sir. But actually,
Then
I
I
am
think
facing a lot of issue to learn this role because it's a role for very experienced people, not for fresher. But I don't know why company want to me in this role.
you see every role product based companies has a different uh, I can different designations, right? Because service-based companies will not be having this much designations, but product-based companies they are handling entire design, right? They will be
Yeah.
having all these designations. So it is like if you have very good package, then you stay back. That is best thing. But
Okay.
see, it is like every point of time you should be improving. See, when you learn physical design, it's not only physical design, right? Later you should also learn the synthesis also. HT also, if you
Yeah.
want to improve, see, your role will change stage by stage. First, you will be a block level engineer. Next, you will move to a lead position. Next, you will go to the manager position. Manager position means you should handle from the synthesis to the end, GDS. So when you become
Okay.
still more to go to the next level, then your role will be like you will go to the director level. You should learn from the beginning to end. You should be knowing from RTL to GDS. You should be knowing. So your role will increase when you get experience. So if you get the knowledge, I think it is not of waste, right? I can
Okay.
support you, but I will not suggest like leave the company. If it's very good, package is very good, then staying back is a good suggestion.
Okay,
But
sir.
but I will tell you everyone, even including me. So learning is a continuous process. So you should be parallel. You should be learning when you are working, right? You should be
Sir,
either
what I
learning through
want.
the experience. For example, you are a
Okay.
fresher. You cannot learn. You cannot take up the new course immediately. Please allow me
Yeah.
to complete the new course. When you are a fresher, you
Yes,
are
sir.
in some role. You cannot
Mhm.
take up the new course immediately because you are in
Mhm.
the learning phase inside the company itself when you do the project. That is new to you. So you are in the learning phase.
Yeah.
So, but if you are doing the same project three to fourth time, it's like just so go sit, do the same work and come back. At that time, there is a new learning requirement. Then you should be seeing some other new course to learn. So you are in which phase in that? What I told.
Yeah, sir. Sir, actually, what I want now, I want to continue in that role, and from here, like from your course, I want to learn PD, and after that, I want to apply in another company. In that company, I will work in that company in both roles, system architecture as well as in physical design. So, is it
Then it is
work for
very
me?
helpful. Then see
Because
if
I
you are
have
having
I
this,
Mhm.
this is very helpful.
Yes,
This course is
yeah,
very
because
helpful.
I have a tag from the very big company, and on behalf of that, maybe another product-based company will take my interview as much as possible because of the tag.
Yes.
And
Yes,
in
yes,
that
that is
resume, I will show I will work in this company in both roles, like system
yes,
architecture as
yes.
well as in field. So that this will help me to.
See
Is it
if
a
you have planning of shifting to this
Mhm.
dual role, like if any other company who is going to give you this role, then this course is very
Mhm.
helpful.
Yes, sir. Or in this
I think
experience
this
letter.
knowledge will not go off waste when you are even working as system design architecture, right? This
Yes, yes,
knowledge
sir.
what you are learning from this course will not go off waste. Somewhere
Yeah,
other
I
way
know
you should.
because indirectly in physical designing, what we want to optimize our design, gate labor netlist,
Yes.
and in a system architecture, whatever I did in Synopsys platform architect tool, that tool is also doing the same thing, but at the architecture stage.
Yes, yes, correct. The same thing I'm telling you, right?
Yeah.
Even what if you
Mhm.
learn this physical design, your this knowledge will not
Or,
go waste for the architecture engineer. You will be
yeah,
knowing this. You will be
yeah.
implementing this one or the other way.
Also, I have one more doubt. In my experience letter, should they mention I am working in this role, or is just like experience letter only?
What you're telling, I
Hello.
didn't understand. You're
Actually,
getting
I am asking if after 1 year or 6 months, if I will leave my company, then in that offer letter, in that experience letter, they mention like I am working in this role, or only they give me an experience letter. Okay, this guy working in my company for 6 months or like that.
they will give even the role also. What role is
Even the
working?
role also. Okay, okay.
If if they give like Deepak was Pratik was working, right? The name is Pratik. Pratik was working for 5 years in my company. I can tell that I was worked in manager role also, right? I cannot claim like that. So
Mhm.
they will mention the designation also. In which role? See, they may mention the designation like system application engineer or physical
Okay,
design
no.
engineer, senior physical design engineer. So they will mention the designation also.
Okay, okay, sir. Okay, thank you, sir.
Thank you.
Hello, sir. Uh,
Yes, please. Tell me.
are you going to teach the cadence tools as well? Like only the synopsis tools you are confined to?
Getting one license only is very difficult. See, most of the
Yeah.
company uses Synopsys only,
Yeah.
but few company uses Innovus. So Innovus is used by Qualcomm for PNR. Even Qualcomm is also using. I cannot deny that they're not using Synopsys, but Intel totally uses this one only, right? What is that?
Synopsis.
Intel, Samsung, right? They use only the Synopsys tools. So they will never
Yeah.
touch. But Qualcomm is not like that. Qualcomm uses both the tools.
Okay.
So see, getting tool itself is very difficult. So we have here Innovus tool, sorry, Synopsys tool, that is a ICC tool, or we may
And
migrate
the
to
compiler.
Fusion compiler also. Both are same. Fusion compiler
Okay.
will come with different licenses. That's it. Both usage is same. So we will use either Fusion compiler or ICC2 for the design.
Okay, sir.
Use only one tool.
Okay. Like, there are any companies like only in which they only use the Cadence tools?
Yes, there are few companies, like some
Okay.
companies like R, they use only Cadence.
Okay, sir.
See,
Thank you.
you migrating from physical design engineers need not to worry in which tool you are working, because the companies will give you the script to work. They'll give the
Yeah.
flow to work.
Yes. You're right.
But
Yeah.
you should be knowing how to use the tool. That is one thing you can learn it. I think with the help of others, right? You can learn. See, knowing the tool is not a very big thing. So you have different options to know. For example, if I want to get any command in the tool, you should be knowing the technique how to get the command. Like help, I want to get the command. What is the command for floor planning? So I will tell like there is a command called as initialize floor plan. I don't know the command, right? What I will do is I will use help star floor plan
Yes.
star. So my tool will give what are the commands with floor plan. I can do man on this command. The manual
Yeah.
page will explain what this command will do. Like that, we can learn the tool. And even we have
Okay.
user guides. So user guide will help you to understand how to use the tool.
So if you know what to do, then whatever the tool may be, we can know the like using the man um using the man as you said, we can use the tool as well. Any tool.
The company has, when you go to company, for example, now you have worked on synopsis tool, you assume.
Okay.
So now suddenly you're going to company, the company is offering you the Innovus tool. It's giving you Innovus tool. But
Yeah.
learning is totally your part.
Yes. Yes, sir. You're right. Yeah.
Yes, sir. Now, so what is the doubt you was asking? I forgot. Okay, see, now when suddenly if you go into some company, right? See, company
Yeah.
has three phases of working, like minimum, when like P1, P2, and P3. So P1 is a trial run phase.
Okay.
Design whatever they are giving is not the actual run phase, it's a trial run phase. In trial run phase,
Oh.
you can learn. These trial run
Yes.
results are not at all important. Whatever results you get right is not at all important. It is for you to learn about the design, how the design behaves, what is the thing. In P2, because P1 is running means still synthesis is not fully completed. Still some teams are working on the synthesis result. Right? So during P2 again netlist will change, small change in the netlist. So that is called as P2 stage. So here
Okay.
result little bit matters. P3 should be having very good result. So in the
Hmm.
P1 stage you can learn how to use the tool. So it's not that directly you will go into the direct last phase. So you have
Yeah.
different phases. So in the first
Thank you.
phase you can learn how to use it.
Yes. Yes. You're right. Thank you, sir.
So I and one more thing. See, I have used both the tools. I have used even Synopsys tool, ICC2, and even I have used Innovus tool also. Right?
Okay, sir.
There is a significant difference between both the tools using. And it's not like one tool if you use, you cannot use the other two blindly. Other tools. There is a little bit different in using the both the tools. But you have
Okay.
user guide. Every tool is giving you user guide. If you go through user guide, you can understand how to use the tool and learn one tool properly. Then you can correlate with other tool. If possible, if I am continuing the classes, I will tell you what is the equivalent command in Innovus also
Uh,
when I am doing it. I will not take the
thank you.
labs. I do only weekend theory. in theory also I use some lab content also. I'll do some lab also when doing the
Okay.
advanced thing. It's not like
Yeah.
theory means not only doing the PPT. We will also use how the design is behaving. I'll also do some tool content also. In that I'll tell you what is the equivalent command in cadence. We'll also
Okay.
tell that. And even I can also share some notes on that, right, if possible.
Yeah. Thank you, sir.
But here you're using
Yep.
the tool called a Synopsys. Hands-on you're doing on Synopsys tool with ICC2 or Fusion Compile. So currently we have ICC2. So if we go for renewal, we may get the higher version called as Fusion Compile. Both are same. Commands are same. Fusion Compiler has some advanced. We can invoke more license by using Fusion Compiler. Separate license is not required for synthesis. Separate license is not required for timing sign-off. So all license will come under one bundle. That is called as Fusion Compiler.
Fusion
But
Hub.
usage is same. Fusion Compiler
Yeah.
and IGC2 using methodology is same. Only licensing is different. That is you are nowhere involved. That is licensing team is involved.
Okay. Okay, sir. Thank you.
So price. So if
That is you talk with insurance. See, you have your own project is what you will bring, but you should get the netlist or you should get the RTL. You can ask the admin to load in the server. See, tool we are not going to give you outside. Everything what you do in the server only. You can ask the admin to load this RTL and RTL. That RTL you can synthesize. Then you can do the physical design. Your design is very simple, it will be because it will not be having any macros. If design is not having macros, it's very simple. If design is having macros, then only design is very complex. You can do it. In server. You do it. You can do the same steps, whatever we are doing.
So I heard about
Argot is a see industry uses cells with 10 to 45 lakhs, I told. But I cannot work on the design. I cannot give you the design with the 10 to 45 lakh cells because there one command is taking 3 days to run. Here I cannot do that, right? In teaching course, I cannot ask you to wait for 3 days and come back. So one command I'm telling. So like that, you'll be having hundreds of commands in the physical design. I cannot ask you to wait for that time. So we use little bit lesser complex design. So we will work on the design which is having 50,000 cells and 40 micros. So I cannot bring the design which is having 2 lakhs or 3 lakh cells because the runtime is very huge. Here only if you use the command like place soft, the command takes 1 hour to run. Doctrine synthesis is taking 4 hours to run. Routing is taking 5 to 6 hours to run. So, and we have many students to work. We don't have only this batch. Parallelly, many batches are going on. So I cannot bring that complex design and I cannot ask everyone to run. First thing. Second thing is if you want to run that bigger design, right? You require more cores from server. Server CPU has how many cores? Like 8 or 16 cores. So you require 32 cores, 80, 64 cores. Then only your design can run very fast. That much resource we cannot give from our server for one candidate. How many candidates will be having? Per batch will be having 40 candidates. 40 candidates, if you give that much resource, we want big servers again. So we cannot do that. So we work on a little bit lesser design. See, none of the company will ask you in which design you work as a fresher because they want a real-time experience. When you claim as experience, experienced candidates requires the complex design. Fresher, fresher, they will ask whether you know all these concepts are. So we are giving you the tool to understand this concept in better way. So to understand how to use a tool for any purpose. So none of the company will ask you whether you're not done on the bigger design. Companies know that because to do on the bigger design, companies are working on 7 nanometer, 4 nanometer, but we are working on 14 nanometer. Why? Why institute are not working on 7 and 4 nanometer? Because companies have MOU with foundries. Foundries will give the files for companies, but institute cannot have MOU with foundries, right? We have to pay in crores to make MOU. We have to depend upon some file which is given from Synopsys itself. Synopsys tool only will give some inbuilt files, library files. We have to depend upon the file which is given from Cadence itself. That's called as rack. We have to depend on those racks itself. So what racks they are giving, we are going to teach on those racks only. So we cannot get the files from the foundry. If you want to get the files from foundry, right, we have to pay in crores, not even in lakhs. So every institute will do the same thing. They will do, none of the institute will do in 14 till now. They simply claim as 14. They'll do on 28 only. 28 is a maximum. Maximum free of cost available rack is free of cost means this rack is available for only the person who is purchasing the tool. Tool cost is only like 80 lakhs or 90 lakhs for us for 1 year for 25 license. Right? So for them, the rack is free of cost. Rack means the files, input files, like .lib, left file, lib file, these things. But in the industry, what is working industry 4 nanometer, 7 nanometer. If you want to get those racks, you have to pay in crores for the foundries or the PDK team. The PDK team is only present in product-based companies. Intel is having PDK team, Qualcomm is having PDK team. We cannot purchase from them. They will never give to you. Even you will go to company. Even if I ask any information from your company, even you will not give it because it's very highly confidential. If the company knows that you are leaking this information, they'll remove you from the job. It's very difficult to get from industries. So we depend on what we get. Okay? So we teach it in that. So any other information, any other doubts you have?
Hello.
Yes, tell me.
Yeah, hi, sir. Good afternoon.
Yes, please tell me.
You told that every record section will provide the 15 days once, right?
No, it's not 15 days once. I told that video is
Then,
available for 15 days, next to 15 days. See, today if I take the class, after 4 hours, they will upload the video immediately. If I take
okay.
class, my class will close at 12:30. This video will
Yes.
upload in the server. It takes 4 hours to upload because it is in GB.
Okay,
They'll
okay.
compress and they'll upload. After 4 hours, that video is already available to you. Means at 4 o'clock or 5 o'clock, the video is available to you, recorded video. This video you can see only for next 15 days. After 15 days, they'll remove this video. It's not that we are
Okay.
going to upload after 15 days. We upload immediately, but that video is available only for 15 days. After 15 days, it will refresh. Tomorrow's video, tomorrow only it's available. But after 15 days, it is removed. Yes. You got it? Any doubts you have on
Okay.
this?
No, sir. Thank you.
The
So you
new
will get
batch
two videos.
coming
I've
from
already told you. You will get live videos and you will get pre-recorded videos. So pre-recorded video is present for entire course duration. But live recorded video is available only for next 15 days because we are having plenty of batches running. If we keep for 3 months, right, we don't have that much space to keep it. See, we are also depending on third-party server to give the access, server access. So for that reason, we cannot keep it for more time. Yes, tell me, any other doubts?
it will last long for only 15 days, right?
Yes, live recorded videos will last for only 15 days.
The new batch comes from which day, sir?
This demo batch, right? See, if you start
Yeah.
from basics, if you opt from basics, it will start immediately from Tuesday or Wednesday. Admin will inform you.
Okay.
Immediately, one day they'll give the time. They'll start from tomorrow itself, but I think they'll do some giving basics. If the students are interested to attend tomorrow only. But digital, so starting course will be like a digital course.
Fine.
This course is
Is
starting
there
course.
any batches
They
in
will, I think they'll start from
yeah,
Tuesday or Wednesday.
okay,
They'll
in
inform you.
coming month?
So you are registered. You are registered,
Yeah,
right?
I
Like
have.
if you pay 5,000 and if you register, they will inform you.
In the coming, I'm asking about in coming month, which means in May month, is there any batch? I'm asking.
Yes, batches will start for every month.
Batches
But I
will
cannot
start.
tell you what is the date because
Okay.
batches will start for every month. Every 40 days or 50 days, the batch will start. But I cannot commit what is the exact date. So you can wait, you can ask for admin or you can
Okay, which means
query with
from
admin
tomorrow
internal.
it started means after 40 days it will start. Huh? The
Within
next
40
batch,
days.
I'm asking.
Yes.
Yeah, yeah.
Yes.
Thank you, sir.
Again, next batch will start in month of May again.
Okay, sir. Thank you.
So any other doubts?
Sir, how the
Okay. Yes,
doubts
tell me.
after the class being addressed? Like how we can ask the doubts after the class?
Every class is a live session, first of all. None of the classes are
Like
recorded. So every
like
class is
after
a
the
live
class
session.
in any
And
time,
you
like
can ask. Yes, I'll inform you. I'll explain. You can ask during the course time only. First thing.
okay, okay, sir.
Second thing is, right, you can, if you are in the institute, you can meet the mentor. Mentor is available for 24/7 in the institute. If you're coming to institute, you can meet the mentor. Third thing, if you have any other doubts, you can post in the individual WhatsApp group. I told you, right? If you register for
Okay,
course, they will create individual WhatsApp group for every student. You can message in individual WhatsApp group. So that will be addressed by the admin within 4 to 5 hours.
okay, sir. Subject related doubts we can discuss with the mentor. Like uh, are we added to any group, WhatsApp group where mentor is also added?
You cannot ask in the live, like all the students are present, right? There is one group. In that group, you cannot ask because it will disturb everyone. So there is
Yeah,
individual WhatsApp group. In individual WhatsApp group, everyone are there. I already told you.
yes,
Owner will be there, admin will be there, office staff will be there, and even a mentor or trainer will be there. They may add if on request, right? If you request, probably they will add 24/7. They will add. So in that, if you ask, the trainer will message you, reply you.
okay. Thank you.
And sir, is there any weekend batch also? Hello. Is there any weekend
Yes,
batch
training.
also you running, sir?
Weekend batch?
Yeah. Is there any weekend batch also you are running?
Yes, I already told you, right? We have two batches. Like basics, we don't have weekend batches. So advanced physical design, we have weekend batches. If you want to do basics, you should depend upon the record videos, like live record videos. Basics, it will run from Monday to Saturday. Then only we can complete the basics. Right? Basics are also we cannot complete within 2 months. Basics means we will start from scratch of digital and it will entail PD basics. CMOS,
In
everything
case,
is start
in
from
case a
scratch.
person who is with nil knowledge also, he can understand huh? That you said basic.
Basics, digital is not much important, but you should be knowing what is TCL and a little bit of
Okay.
CMOS. CMOS means what is layout. But TCL and JVM, I think it's not, no one will know because it's not part of syllabus, UG syllabus.
Yeah, yeah.
So UG
It's
syllabus,
in a
right?
separate
Whatever the
part.
college syllabus you have, GVM and TCL is not a part of that. So then you should be
Okay.
knowing that.
What is required, you will learn us.
Yes, GVM, TCL, everything will be, all these concepts will teach in basics.
Okay. Fine.
Just a one clarification, because I was looking for the weekend, as you mentioned that basic is on only weekdays, like Monday to Saturday. So as I'm working, so I could not attend the live sessions. I will going through the only um, recorded classes for the basics. That will be correct, right?
Yes, recorded live sessions will be given. You can go through that. If you can attend the classes. For that reason only we have given that. And if you have any doubts, you can discuss on individual WhatsApp group. The mentor will be present.
Okay. Yeah.
But advanced part, even you have weekend, any of theories on weekends only, and you have labs even on weekends. You can do hands-on and theory both only on weekends. So then you will be having 6 hours of class because theory is 3 hours and lab is 3 hours. So morning theory and afternoon lab. Only on weekends. So the student who is opting for weekdays, they should attend only weekend theory class on weekends, and weekdays they can attend what? Lab classes. Both are different. Weekdays lab and weekend lab both are different. Don't attend both. You'll get confused. Attend any one thing.
Sir, I have a FinFETs. I had a FinFETs.
See, FinFETs or MOSFET, we need not to worry because that is handled by layout team. Because layout is already drawn. So we should depend on, we should worry on some other aspects. But still, FinFETs is the transistor level. FinFETs, see, till 14 nanometer technology. What do you mean by technology? Channel length. So till 14 nanometer or 16 nanometer, we can use MOSFETs. After 14 and 16 nanometer, there is huge leakage current. Even when we don't apply the gate voltage, the current flows between source and drain. So this leakage current we cannot stop only by using one gate. So we go with FinFETs to reduce this leakage current. So we use structure called as a leakage current below 14 nanometer. So FinFETs
Sir,
layout is done by layout team. So we should only know how to use it. We not to bother about that FinFET or MOSFET. Both seems to be same for physical designing. Yes, tell me.
sir, are these two things go parallelly or simultaneously? The basics and the advanced physical design.
No, no, no. First 2 months basics. Next 3 months it is advanced course.
Okay, sir.
First 2 months is only basics. See, after completing basics only, you can understand the advanced concepts. See, I told you digital is not of much important for physical design, but digital is important when you go for interview. See, if they ask write the structure for mux, and if you tell don't know, then it's the interview is gone then only, right?
Yes, sir.
So for that reason, see, if they ask write the structure for D flip flop, what's the difference between asynchronous design and synchronous design? If they ask these basic questions, if you tell you don't know, then the interview is gone there only. So for that reason, the digital is
Yeah.
important. Apart from that,
Yeah.
you can understand the advanced class only if you know TCL, only if you know
Yeah.
CMOS basics,
Yeah.
only 3D basics. So first 2 months is basics, next 3 months is advanced class.
Sir, what is the meaning of like 14 nanometer? What exactly it is? Like
Is the
7
distance
nanometer.
between source and drain.
Distance between the source and drain. Okay.
Source and drain. This distance.
Okay.
This distance,
Yeah.
minimum distance is 14 nanometer. The distance cannot go below 14.
Yes. Okay, sir. Thank you.
Yes, thank you. Then we'll continue. So remaining everything admin will contact you or you can contact the admin.